Assalamu alaikum, my name is Muaz bin Al-Jamal. will present the answer to my EA starting from question number 1. So the question number 1 asks us to design a process plant, a single line diagram that connects from the grid to the load. So it must have a backup generator, the emergency for emergency load, and it must have at least 3 buses. Represents power system. Yeah, must have at least 3 buses. So basically this is the power system that I designed. It starts from the utility and moves on to the transformer to transform this 2 steps down this 132 kilovolt to 6.9 kilovolt for the application. And then we have the backup generator of 10 MVA capacity and 6.9 kilovolt nominal voltage, and the transmission line goes to bus number 3 that has the load or motor, and across the line we have the relays for question number 3 later. And these are the assumptions made below. So basically these values are actually obtained from the simulation, and these are the assumptions for question number 3. TMS equals 0.4, 0.4, and the plug setting 100% and 60%. So moving to question number 2, we have a double line to earth fault, and we have to calculate with and without fault impedance. These are referred to question number 1 as well, and these are the formulas used and the circuitries, and then the standard formulas with ZF. So once we're calculating without ZF, so ZF equals to 0, and we also have the formulas for voltage, and we also use this formula, the essential formula for calculating the phase current using the sequence currents. So with ZF, these are the values that we got, and I equals to 0, which validates this formula. I is equals to 0. Basically we just add up all these magnitude in PU, and essentially we got 0, and these values are not the final one, so we need to calculate it using the base current by multiplying it, and then we can get the real current in ampere. And then we continue our calculation with voltage. So this voltage that we obtained, that is already times by the base voltage, which is 6.9 kilovolt over square root 3. And then for without ZF, these are the values, the same process, but just without the ZF or ZS equals to 0. And then we got the magnitude IA equals to 0 again, and then the same magnitude for IB and IC. And for phase voltage, for VB and VC we got 0, and VA equals to 0.4906, and all the sequence voltage are equal. Moving to the question number 3, we design a circuit based on the question number 1 to simulate it, because we want to look for the values for IF for every buses. So bus number 1, bus number 2, and bus number 3, that is used here for the calculation for question number 3, and then we use this formula to calculate everything. So based on the assumptions made, and we continue to calculate for every relay. So the first relay started with calculating the time, because we already assumed that TMS equals 0.3, and from the time, this time we use for relay B, because TB equals to TA, because they are within the same feeder, and the TMS we got is 0.3 and 0.31. And then relay C we must minus by 0.4, because it is between the feeder, so it moves the feeders, and we need to minus by the grading margin, which is essentially 0.4. And then we got the new TMS and TMS for EF, for OC and EF, and we renew the TMS, the time, because the TMS is not exactly it is. So it might have like some more decimal points, so we have to use the exact values for 0.37 and 0.32. So these values are then used for TD, so TD equals to TC, and the same calculation as well with the we have been always changing the current from the current transformer here, so it's 300 120, but essentially from you just use the same formula until relay E that calculated, and we got 0.1 0.04. So basically the system will treat based on the time that has been determined using the TMS, and based on the current settings as well that we have calculated that I have calculated from the current transformer.